2.4 part 2 then is going to be continuing on with our division of polynomials, but we are going to specifically look at something called synthetic division, which is going to make it's a quick way with long division, but we can't always do it. And then we'll talk about the remainder and factor theorems, which is going to help us find some zeros really quick to test if they are or are not. So synthetic division, like I said, is a quicker way to divide polynomials. The problem is we can only use it when the divisor is of the form x minus c, meaning the coefficient of x is 1 and it is a linear, meaning no x squared or x cubed. Okay, now obviously also we could say it's x plus c, and remember the c's are going to change the sign, so it's going to be opposite. So x minus c, we would use c, x plus c would use negative c. And now in order to do this, we're going to start by writing our coefficients in descending order. So also here, make sure you pay attention, coefficients, which means no x's, and with c in left to the box. So c is what is from our divisor. Okay, after we do that, we bring down our leading coefficient, meaning our first term's coefficient, and then we multiply that by c. So multiply the leading coefficient by c and write the result under the next coefficient. And then we add those two, so that result and the next coefficient, we bring it down, and then we're just going to repeat steps c and d. So multiply and add, multiply and add, multiply and add until we are done. Now again, I understand that probably sounds like a lot of information in a short amount of time. It's not as difficult as it may seem. Looking at an example, I'll show you why. So first thing I need to look at this and say, okay, what is c? Well, c is negative 2, because remember it needs to be opposite. So I'm going to write that in a box to the left. The next thing I'm going to do is write my coefficients in descending order. So I see an x cubed is highest, so I'm going to bring a 5. Now here's the trick. There is no x squared term in this, so we need to make sure we include that as a 0. And then we go to our x, which is a 6, and then our coefficient, which is an 8. Okay, after that, I'm going to draw a line under all those. Remember, next step is to bring down your leading coefficient. I now multiply my leading coefficient by c. I get negative 10, and I write that under the next coefficient. Add these two together, which is going to give me a negative 10 again. Repeat the process. So I'm going to multiply again, which is going to give me a positive 20. Add them together, I get 26. Multiply again, and I should get negative 52. Add them together, and I get negative 44. Okay, so really it's just a process of repeating multiplication and division. And what this means is if I take these two polynomials and I divide the first one by x plus 2, these are going to tell me what my coefficients and remainder are. So in this case, since I divided an x cubed by x, I would get a 5x squared minus 10x plus 26, which you see I got from these first three terms, plus our remainder in this case is negative 44, so I write that as negative 44 over x plus 2. If we did that division, instead of doing long division here, you see we'd get this quadratic with a remainder of negative 44. Now the remainder theorem and the factor theorem, what that means is the remainder theorem, if f of x is divided by some term x minus c, then our remainder is always going to be c, meaning just plug in c here to get your remainder. Our factor theorem, and this is a good one, if f of c is 0, then I can say x minus c is absolutely a factor of f of x, and that'll probably help me find my other factors. Likewise, if x minus 6 is a factor, so we're actually just saying the same thing backwards here. If x minus c is a factor of f of x, then that would tell us that f of c must be equal to 0. So it's a good way to check to see if something is a factor or not, just by plugging it in real quick. An example of that, if I have f of 4 here, I can plug in f of 4. So I'm going to have 2 times 4 cubed minus 11 times 4 squared plus 7 times 4. And if we plug that into our calculator, so 2 times 4 to the third minus 11 times 4 squared plus 7 times 4 minus 5. That would give me negative 25 as long as I did the math right, which means if I did long division, so if I said, or if I did synthetic division, either one, if I said 2x cubed minus 11x squared plus 7x minus 5 divided by x minus 4, and I get x minus 4 because that is c, so it's x minus 4, I would get a remainder of negative 25. If I did that whole process, I'd get a remainder of negative 25, which means also that this is not a factor, okay, because it would have to be equal to 0. And that gives us a just general idea of our factor and remainder theorem. All right, so that is it. Like I said, synthetic division is a little quicker than and easier than long division. Remainder and factor theorem are just going to tell us if they are a factor and or what our remainder would be if we did some either long or synthetic division. See you next time.